In this video, I want to show you how to compare two spectra. In this case, we have a theoretical and an experimental VCD spectra to compare, and we want to overlay them as best possible to see if there's a match. We see the theoretical data being shown here in blue, and so that data comes from, we're labeling it theoretical raw here. Frequency is on the x-axis, and the VCD rotational strength is on the y-axis. The orange graph is the experiment. Again, frequency in reciprocal centimeters on the x-axis, VCD rotational strength on the y-axis. At first glance, these don't compare all that well. This is because the scale, the y-axis, is never going to be the same in the instrument as it is in the modeling. That's dependent on concentration and other conditions, and so we're never able to match the y-axis scale. It appears like our theoretical spectrum has peaks that are about 3 to 4 times greater than what we see in the experiment. So what we'll do is we'll scale back the theory by that factor in order to get a better view on the match. The other thing that you notice is that the spectrum seems to be offset. See these two peaks right here? The blue is a bit higher frequency, so these need to be shifted back to align with these two peaks that we see here. And this is quite common, that the theoretical spectrum coming from an electronic structure calculation will give frequencies that are just slightly higher. It's because of the harmonic approximation. And you have to scale them back by a little bit here. Let me show you how to do this scaling, and it's something that you can sort of manually do to fit it until you visually see that the two spectra are compared well. So we can move this over for the moment, and we're going to come over here and create in columns E and F a new set of data that will have the same labels here. So I'll just copy that over, and we're going to have at first some scale factors that we put in the top here, and I'll make that scale factor just 1 for the moment, and we can alter that according to our convenience. Format this a little bit, make sure we've got a few more decimals being shown. Okay, so I've got my two scale factors sitting in top of the columns, and I'll just come under the frequency column here, and remember, we're going to leave the experiment alone. We won't change that. We're going to modify the theory to try to align the spectrum. So I'll just come into this cell and I'll type equals. The scale factor is in E1, so I'll put $E $1, I don't want that cell reference to change when I copy down, times A3. And I'll do the same thing over here, equals $F $1 times the VCD rotational strength. And I can copy that all the way down, matching the theoretical data here. So right now I've not changed anything. I can go over here to my graph and redefine the blue line, select data, and edit the theory so that now the x values are coming from column E instead of column A. And the y values are coming from column F instead of B. Okay. So now I see plotted this scaled version. It's the same because scale factors are 1. But now we can begin to play. Let's try a scale factor for the frequencies, the x-axis. We want to move them back a little bit. Let's try 0.98 to start with. That's a commonly used scale factor. You see it's almost there, almost aligned perfectly. If we want it to be more perfect, maybe we want to go a little bit further, 0.981. We'll let you play around with that if you want to get it more precise, but actually right now it looks pretty good. How about the y-axis? We said we're going to scale back by about a fourth or a third. So let's put that in here as 0.26. We'll try that first. And magically the spectra is aligned quite nicely. This would probably be very good for a fit. So we can change these numbers as much as we want manually until we get the fit that we want. We can even, since we're talking about VCD, let me note for purposes of comparing an enantiomer, suppose you had actually the enantiomer in the theory. Well, that could be dealt with very easily here by this scale factor for the y-axis. You could just put a negative number in there for the scale factor, and that will flip. And so you can see that this is an anti-correlation between the two theory and experimental spectra. If that happens to be your case, in other words, if you had in your theory done the enantiomer and you wanted to do a direct comparison, you could just do that by using a negative number for the scale factor here. Well, hopefully that gives you the tips that you need in order to get started with comparing spectra.